Welcome all you to this paper class that today we are doing Unit 5 Energetics paper class. My last recording, I've sent you guys this revision of Unit 5. So for new students, I'm just saying I have done all this starting from first unit to fourth unit. We are done completely revision, analyzing all questions, writing, reviewing and everything. We are moving on to the fifth one. After fifth one, the sixth one, inorganic, which is really, really important that you're going to get like 25 marks out of full marks that I'm going to do physically together with you. Up to that, let's go like this because now the time is really, really critical. So the maximum effort I'm just putting to save this time. And our target is, my target is, your target is exceed this. Exceed this. Okay. This picture is from British Columbia, Canada. This is the Okanagan Lake. We went there for a couple of days. We had fun. We did camping and we had swimming. Very rarely, you can swim there. Canada is, the super cold country. So that is my experience. I'm sharing always with you all these happy memories to inspire you about the beautiful life ahead of you. Okay. Wow. See the beauty of Canada, the tidiness of Canada. This is on the way to Okanagan Lake. Okay. Question number 1. The two enthalpy changes are given below. Enthalpy change for the reaction is asking. When you are doing enthalpy calculations, the very first thing is just to write almost all the time. There are these exceptions that you would understand with your instincts. When the reaction is not that prominent or when the reaction is very small reaction out of all the given reactions, then we don't write it to the main equation. Otherwise, almost all the time, we are writing the equation for the given reaction. So this is a given reaction. This is the enthalpy that they are asking. But they were given two data. If you analyze that you can see both are giving this common product. So I'm going to stop there. I'm just writing that common product here and going from triple bond to this benzyl alkane. So they are given the value as A. And then from double bond to this same compound, the value is B. Okay, so from triple bond to A and double bond to B. And so that we have two different paths. All these arrowheads ended here. All these arrow tails started from here. So that we have two different paths from here and all the way down there here. And directly the green path, the direct path is from here to here. So we have two different paths we can write. If you want, you can write delta H plus B equals to A. So that you can directly write delta H equals A minus B kilojoules per mole. For this question, answer is question number 5. If you remember your organic chemistry, this reaction we did under organic chemistry, this is the conversion of alkyne to alkene. We need these mild reducing agents. That is called Lindlar catalyst / H2, hydrogen, palladium, barium sulfate, and quinoline. That's organic. You don't want that part to answer this question. Anyway, we are familiar with these reactions. Question number 1, answer 5. If you are a newcomer, so just separate. See, I'm just using these light or any sort of pale color line to separate each of these. So whatever you are writing in between belong to that question. Okay, make it more neater like that. See, I have been using green color ever since because green color is whatever you can write on green color. Okay, so the next question is really, really easy. Which of the following changes are most closely connected? Formation of magnesium fluoride. Magnesium fluoride. So formation enthalpy always going with 1 mole of product. So the correct answer is fourth one. Fluorine solid wrong in the first one. Magnesium gas wrong in the second one. Half fluorine and here MgF is wrong. Gas, half, all are wrong in fifth one. Okay, more suitable correct one. Question number 2, answer 4. Question number 3. Certain salts can insoluble in cold water but dissolve on warming. By heating, since you guys done chemical kinetics, by heating we increase movements of ions so that solubility is increasing. So the best example is these three precipitates, because they are giving different observations while heating. Usual colors, solid colors, lead chloride, white color needle-like structures, lead bromide, white color normal crystals, lead iodide, golden yellow scales. Oh, I'm just saying golden plates for make it easier for you to remember. This is your inorganic chemistry, okay? So you guys know when heated, all these three are resulting color solutions. When cooling down, reprecipitates lead chloride white needles and lead iodide golden plates. So the first statement is correct. The second statement, the enthalpy of solution increases with increasing entropy. Enthalpy is temperature independent. Enthalpy cannot change with temperature. Enthalpy, entropy, so both are temperature independent. Question number 3, first statement correct, second statement incorrect, answer 3. Question number 4. Average bond energies of C triple bond N and C single bond N, they were given. They're asking average bond energy of C triple bond N. There are two methods that we can follow. See, here, C triple bond N mean, so the first method, I'm just taking this one. Answer number 2. C triple bond N mean you have 1 sigma and 2 pi bonds. C single bond N mean just a 1 sigma. If you add these two together, then you have 2 sigma. Sigma and sigma, 2 sigma plus 2 pi. If you divide that by 2, divide that by 2, remaining only sigma and pi. Understood? So in the Cn double bond, you have sigma and pi. So I'm going to do same to these numerical values. C triple bond C 837 plus C single bond N, that is 347. If you divide that by 2, they are not asking the answer, but you are getting answer number 2. Then, or otherwise, what you can do is, this is the sigma plus 2 pi, that is C triple bond N. Okay, C triple bond N. If you subtract sigma, then what happened? You have sigma plus 2 pi minus sigma. Sigma, sigma cancelling off. Remaining become 2 pi. 2 pi. I'm going to do the same to these numerical values. C triple bond N 837. C single bond N is 347. Okay, this value, that is 2 pi. If we divide 2 pi by 2, that equals just a pi. So that pi equals this value divided by 2. So this is the value for pi. And value for sigma is Cn, which is 347. Pi bond plus sigma. This value is this plus sigma. So if you go through, you can get the exact same answer. So there are two answers. Question number 4, 2 or 4. Question number 5. The standard enthalpy of formation of all elements is taken as 0. No. Naturally existing allotropic forms, enthalpy is 0 either for most stable or most abundant. Therefore, even when in chemically uncombined state, we cannot say all are 0. All are not 0. First statement wrong. As elements are not in a chemically combined state, their enthalpies of formation equals 0. No, that's not true. Regarding allotropes, the condition is different. Both answers are wrong. Question number 5, answer 5. Question number 6. Describe whatever the energy factor given. So, second one is actually the lattice formation of KCl, potassium gas, Cl minus gas, making KCl solid. Okay, all are correct. Number 3, electron gain energy of hydrogen, gaining 1 electron, making this H minus gas. That's again true. Second ionization of magnesium starting from magnesium plus gas, ending with magnesium 2 plus gas, releasing 1 electron. That's again true. Okay. Combustion starting from 1 mole of combustion. So, and also formation, combustion of 1 mole. Also formation is also 1 mole. So that it is wrong. Combustion means you are burning 1 mole. You are burning 1 mole. Combustion. You can just write here, not the formation, just write combustion. Combustion of 1 mole. So that first one is wrong. Moving into fifth one, formation. We always form by constituent elements which are naturally existing. Ammonia is a compound. You're going to start from nitrogen and hydrogen, making these two. Anyhow, you have to start from naturally existing constituent elements. So that fifth one is again wrong. 1 and 5 both are wrong. Question number 6, answer 1 or 5. Question number 7. They have given this reaction. They're asking this formation enthalpy. Actually, we can say that whatever the standard enthalpy, that is formation, naturally existing carbon solid hydrogen gas. So I'm just writing that equation here. Okay, but they were given data. Combustion of C2H6. And this is the combustion of H2O, formation of H2O, you can say whatever it is. This is either formation of carbon dioxide or combustion of carbon. So whatever the way we can get that, they were just using the word formation here, whatever the reason. Okay, anyway, so if we combusted, maybe this is 2008. I would check. This is not the formation. Maybe this is combustion, I guess. Okay, let me check with the Sinhala one. No, they have given the formation, the word formation, but they were considered it to get the answer as combustion. Okay, so anyway, making this CO2 from carbon, it is minus 394, but we have 4 carbon here. They were given for 1 carbon. Since we have 4 carbon, multiply that by 4. Then hydrogen, burning of hydrogen. Burning of 2 hydrogen is minus 572, but we have 6. So value for 2 is here. Value for 6, you have to multiply that by 3. That is minus 1716. Then burning of this ethane, again, this value they were given for 2, just 2. So we can just go like this. Okay, so we have built up thermochemical cycle, 2 paths from coming here to here, or all the way from here to here. So that this plus this supposed to equal this plus this. Just subject delta H. They're asking about this. The formed one is for 2 moles. So you have to divide that value by 2 to get the answer. Question number 7, answer 4. Question number 8. Precipitation is always also exothermic. Neutralization is also exothermic. I'm just gonna cancel off this second delta H2 and delta H3 because weak bases, weak acids, so on. I'm gonna go with the first and fourth one just to compare. 0.1 and 0.1 sodium hydroxide making, let's say, exactly 0.1 m H2O. If you forget these decimals, just let's say 1 mole of H2O. But here, 0.05 plus 0.05, each has to multiply by 2 because we have 2 H2 and 2 OH. So that is again 0.1 m. Exactly same. The only difference is this is strong acid, strong base plus precipitation. So the highest energy is for delta H4, then delta H1. Then these two are weaker. But this is more and more weaker. Needs more energy to dissociate both these weak acid and weak base. So that delta H3 is the smallest. For strong acid, strong base. So the value dissociating per mole become minus 57 kilojoules per mole. But this energy is absorbing back if your acid or base is weaker for dissociation, but absorbing more and more back if both acids and bases are weak. Okay. Question number 8, answer 5. Question number 9. Okay. This is a normal condition. Formation of water, H2 gas and O2 gas. HH and OO, both bonds are dissociating. If you go with the first condition, if you go with the third condition, both hydrogen already broken, oxygen also broken. Both hydrogen and oxygen bonds are already broken. Okay. So, this formation enthalpy is negative value, but bond breaking is positive values. Yeah, I'm just giving a little example. Let's say Formation enthalpy of water is 50. So this is exactly like you are only making water. So you can say this is exactly 50. So the numerical value is greater to 50, greater to C, delta H3. Then I'm going with the second one. If you compare the second one, they are breaking both hydrogen and oxygen. Whatever the releasing energy, let's say 50. So part is using for this breakage of HH and OO bonds. So that is now less. The numerical value become less. So the least value is for B because it has to break both hydrogen and oxygen. So delta H1 comes to the middle because it needs energy only to break hydrogen. Question number 9, CAB. Question number 10. The standard enthalpy of formation of any compound is equal to the standard enthalpy of combustion. Not always. This kind of situation, it's okay, but otherwise it's totally different. Formation of CO2 equals combustion of carbon. Formation of H2O equals combustion of hydrogen, only with this kind of condition. The standard enthalpy of formation of any compound. No, it's not always. You cannot say for any compound, so that it's wrong. Okay. Second statement. The standard enthalpy of formation of any element at its most stable state is 0. Okay. Generally, we can say because almost all the time most stable is 0. This is correct with the thermochemical concepts, but there are a couple of rare incidents. Most stable is 0, such as phosphorus. Anyway, they were taken second statement as correct. First statement wrong. Question number 10, answer. Question number 10, answer 4. Question number 11. Standard enthalpy of formation of calcium oxide is this. Ions wrong. Calcium gas wrong. Not making 2 moles wrong. Calcium gas again wrong. Okay. So question number 11, answer 5. Question number 12. Largest amount of energy. Weak. I don't consider even this acid base part. This is 0.1, 0.2, but nitric only 1H plus, so 1 water. 0.1, 0.2, HCl 1 molecule, so 1 water. But here 0.1 has 2H plus, 0.2 has 2OH minus. So it is 2 water if it is no decimals. Question number 12, answer 2. Question number 13. The standard enthalpy of combustion of carbon, sulfur, carbon disulfide given. Formation of carbon disulfide liquid is asking. Okay, this is liquid. They were saying CS2 liquid. This is a question they are asking. This is a question they are asking. I'm just writing that. This is the part they are asking. But they have given all these combustion enthalpies. Okay. You can burn carbon or sulfur, or even if you burn carbon disulfide, you are coming here. Okay. So that we can build up thermochemical cycle very easily. All these carbon, sulfur, and carbon disulfide enthalpy values given. Just to balance this CO2 and SO2, this oxygen, we need 3 O2 here and 3 O2 here. Okay, so that this is the thermochemical cycle. One way from here to here, and this is the second way. Or you can directly write this delta H equals this plus this minus this. Minus value become plus here. So you are making just a one carbon disulfide, just the same answer. Question number 13, answer 2. If you are not understanding anything, you can ask me to discuss at the class, okay? I'm ready anytime. Question number 13, answer 2. Question number 14, which of the following statement is correct with respect to isolated system? 3 different kinds of systems: open, closed, isolated. Open system is can exchange matter and energy plus work all. Closed system can transmit only energy. Isolate system cannot transmit both matter or energy or work. So the boundary of the system does not allow matter, heat or work to exchange. That is the isolated system definition. Question number 14, answer 4. Question number 15. CH4 reacting with O2 to produce carbon dioxide and water. They say it is exothermic. And the value is given when the water is in liquid form, that is 890.4. Same combustion reaction. When water is in vapor form, water gas, this is the value. So they are asking this little thingy. See, this time water gas, water liquid, water gas is a small equation. So I would write either combustion of CH for giving water or combustion of CH for giving water gas or water liquid as the main equation. See how easy. I'm just getting combustion of CH4 to give H2O liquid as my main equation. Then by burning same, you can also make CO2 gas and H2O gas. Then the question they are asking is going from liquid to gas. This is the part they are asking. See, we have from here to here and from here to here. Okay. Just these two equals minus 802.4. Just subject delta H. So this minus 890.4 become plus. But here we have 2 water molecules, so divide by 2. So the answer is 44. Or otherwise, if you go with, so here the answer is 44. You can just check, copy down everything. Just make this really nice reviewing note. When it is getting closer, you can use everything for when it is closer to the exam. Okay, the next one. So this is the equation for making liquid water. This is the equation for making gaseous water. We need this. How do you get that? From the given. Let's check. If you subtract 1 by 1, you can get this. But to make it easier, what I did was, I have written this H2O liquid to the front side. So reverse of 1. Reverse of 1 is this. According to Lavoisier Laplace law, so that symbol or sign also reversing. Negative 890 became positive 890. Then I'm adding these two. Then you can get here. So do the same for these two numerical values. Do the same for numerical values. That's for 2 molecules. So 1 per molecule, it is 44. Both methods are here. Question number 15. Answer 4. And I'm going to stop here. I just needed to give you guys something little. In the meantime, this okay. In the meantime, while I'm doing this, some students are writing the papers here. I got to go to them to check them. So anyway, I just need to add even a little to you guys, just to give a little initiation. Next day, we can finish this. We have we have only few MCQs. Altogether, we have only 36. I want to finish everything, but I don't have time today. But still, I promise you guys that I would post at least a couple of questions from Unit 5. Today we did that. And next day we're going to start from question number 16, okay? So bye, take care everybody. I hope you guys would get this benefit. Use me. I'm just keep saying use me.